Okay, in this video, again, we are on the book for Savitch. We are on chapter 2, and we are going to be working on the last section, which is a programming style. So we're working with the programming style on the last section of chapter 2, which to me is the most important part of the whole book. So I'm going to emphasize on this. We have to learn it and apply it to every program we are using in this class. Okay, so why do we do that? Why do we apply any kind of a style? Of course, it's going to be easier to read because remember, you are going to be jumping into other people's program. People are going to be jumping into your program. Yourself coming back to your own program. Believe me, you come back to your program 6 months from now, you don't have no clue what you have done in your program. So it's going to make it much easier to read, much easier to correct, and of course, much easier to change. So that's why we are using styles. Okay, so first thing first is if you have a block of code, let's say you have a if statement, you have a while statement, put some separation between them so you can see where you are, what you're doing. Do the indentation. So when you see a if, everything in that belongs to if is indented, so you know where it is. Some of the IDEs do that for you. So for example, if you are in the Qt and you do Control A to take everything and do Control I, automatically going to format it for you. You can look at your IDE. Most of IDEs have that. They have a shortcut, or you can just go in the edit or somewhere and say format, and it's going to format it for you. So you want to have indentation, so you know all the statements for a block belong to that one. You want to use braces to create groups. And again, inside the braces, you're going to indent, so everything is indented inside the braces. So if it's in the separate line, it's going to be easier to read it. Some people are used to putting their first braces on the first line and everything is indented. That's fine too. So if you look at this one, what we're talking about is, so if I have a if statement, we are going to have braces. So we have braces here, and then everything else inside is indented. So when you're looking at this, of course, right now it's very, very small, but eventually it's going to be bigger than this. You can easily follow that all these statements over here, you can easily say that all of this statement belongs to the if statement. All of these statements belong to else statement, and it's easy to do it. So if I'm looking for true statement of this, something happens, something is wrong, I'm going to go debug it, then I know if it's true, I'm going to look at these things. If it's false, I'm going to look at these things. So let's say it was working for true, but it was not working for false, and I'm trying to debug it. So that's what we are talking about. And the next one is comment. We have two types of comment for C++, one that has come from C language and one that came from C++. So we can have two forward slash, and when compiler sees that, from that point to the end of the line, it just ignores it. It doesn't even read it, doesn't care what you have in there. It doesn't do anything about it. So as soon as it sees two forward slash, from that point to the end, it's just going to ignore the whole thing. So we can use it to explain some parts of our program. So if I have input, processing, output, and I want to separate them, I would have a comment says, this is my input section, this is my processing section, this is my output section. What if I want to explain some part? So the rule of thumb is if you are explaining something a lot, that means your C++ code is not written good enough. So if I put an X in there, I have to explain my X. What is X? What is Y? What is this? What is that? So if you have a lot of explanation, then that means it's not a good code. If you don't have no explanation, that means it's not good. So we have to find a balance between those things. And the next one is the coming in from the C language, that's forward forward slash. And this can go to multiple lines of code. So you can put one of these on the top and then go to multiple lines and put this one at the end. If you're using two forward slash, you have to put it in every line. When first C++ came along, the programmers want to separate the C++ programmer from C language, so they would never ever use this type of comment. So you put this one and then you end it and you can put the stuff in there that's going to work. You could change it. So if I have forward slash a star forward slash, and I want to change it to the double one, then I have to put that for every line. So we want to separate every section to be sure it's visible. You want to put some extra line to separate the codes to know where you are. Next one is called constant, and we're going to train ourselves to use it. So if I am looking at lots of code and I see number 65, I don't know what the 65 is. So a little bit of history. Some of you guys were not even born when the year 2000 came along. The problem was we were using 2-digit for year. And when 2000 was coming around, then 2-digit would go to 00. So year for credit card, let's say we were in 1997. So it would show 97. But if it would go to year 00, 00 was less than 97. So all of a sudden your credit card was expired. So what we did, everybody throughout the whole world, we went to every program. We find 2-digit number. We figure it out if that 2-digit number is a year, and then we would change it to 4-digit number. That means that I had to go along with a lot of people to every single line, look at the number 65 and figure out, is this 65 a date or is something else? So for example, if it's age, I don't need to change it to 4-digit. But if it's a date, I have to change it to 4-digit. So it was a lot of work. It showed that if we get together, we can accomplish some huge tasks worldwide. And some companies went under because they couldn't handle it or didn't have resources to handle it. So we're talking about having a number versus having a name for it. Another advantage is if I have a constant, let's say that I have a constant called retired age, and I use retired age as a word all over my program. And they come back and say, you know what, we want to change retired age from 65 to 67. I don't need to go to every line of my code and find 65 and think about it if this is a retired age or not. Maybe it is something else. And then change it to 67. If I define it as a constant on top of my program, I don't even have to go through the code. I can just go and change that 65 to 67, and it's going to apply to everything throughout the program, for all the programs that I have done. So think about it, that if I had a 2-digit defined on the top of it, and I would go change it to 4-digit. So if I had 00, change it to 2000, then everything would work. I don't have to go through all the lines of code to figure it out. So the book is talking about magic number. Magic number is a number 65 in the middle of your program that if I jump in there, I don't have no idea what it is. So do not use any magic number throughout your program. As soon as I say this, some people go and create some constant variable and they call the constant variable name the same as the number. So for example, they have 10 and they create a variable called 10. That's going to constitute the two things for us. One, I still don't know what the 10 is. Is it an age? Is it the page number? What is it? Second, what if I want to change that to 11? Now, every word that I have a variable 10 contains 11. So do not call the constant number the same name as its value. Try to find some meaningful name for it. So in this case, it has window count set to 10, and throughout the program is using the window count. And if I decide that window count is going to be 20, we just come here and change. A good example is tax rate, and constantly is changing. So if I don't define it as a constant, when the tax rate change, I have to go to every line of program, find the rate, and think about it if it's the tax rate, and then change it. But if I have it like this, I just go in one place and change it. Another thing that's about the constant, nobody can change the value of constant through other programs. So if I define Windows count or retired age, and somebody jump into the middle of program and sees this variable and try to change its content, it doesn't let you do it. So it has to happen only one place, and you can only change it in one place. Okay, so this is what I want to go over it. This is something that we are going to be doing from this point on. So this display 2.17, you're going to go over it again and again and again, and you're going to apply it to every single program you're going to be writing. At the beginning is just some of the new things you might not remember, but as you're doing your peer review, as you're doing these things, then you can, it's going to come to you. So first thing first, what's going on? Okay, so on the top of your program, you're going to have comments. You can put it this way or the other way. So you got to follow this. The last change, generally we use it in industry, that I last night woke up in the middle of the night, I fixed something, and the customer says, okay, my one problem is fixed, but I have 5 more problems. Then the next person who's looking at this program, they see my name here, not to blame me for it, but they're going to ask me, what did you do last night? What was your last change that made some other things not working? So that's what we have this in there. And of course, the program name, sometimes you open the program, you don't know what the name of it is outside of this class, but eventually that's going to happen. The next thing that we want to do is we want to put the constant in there, no magic number. So any number that you have in your program has to be declared as a constant. Next thing is getting some extra line to separate things, so it's going to be much easier to read. So I have my first section for declaring variable, my second section for doing my input, my middle section to do the processing and the output. You want to put some extra spaces around your operand because it's going to make it easier to read. So what I'm trying to say is don't put it like this. So be sure you're going to put some spaces around it. So it's much harder to read this. So don't do that. So you need to put some spaces around your operator. Do not use single character variable. Especially if you're coming from math department, your math major, you want to use a single character. That is not acceptable in this class. So have a meaningful variable names. So you cannot have an if statement So see the difference between if T greater than N versus if temperature greater than normal. It's totally different way of understanding it, being able to read it. So you must follow all of these things in your programs. Again, at the beginning, we are not too harsh about it. We are just learning. We're going to be pointing it out and then work on it. It's not a big, huge thing, it's just a practice. Okay, so what happened to my... All right, so at the bottom, there is a sample run. So we want to add the sample run to your programs. The way we're going to do it, and I'm going to demonstrate that for you. So the way that we're going to do the sample run, we're going to create the comments at the end of your program, and you're going to put your sample run so I can see what you have as a sample run. So first step is to run your program. Go to your console. Some of the programs, some of the IDE give you a console. Some of the program, they just put it underneath. So it's different areas. So you go, if you have a console, you go to edit and you're going to highlight what your sample run is. You're going to copy it. You're going to bring it back to your program and you're going to put it as a comment at the bottom of your program. So every program you're writing, you're going to have a sample run at the bottom. Let me show you what I have. So let's first go with the code block. So code block is using the console. So if I run this, let me move these things away so you can see it. Okay, so if I run my code block, it's going to bring me a console. So if you bring the console up, that can be for Mac or PC, doesn't matter. If I click over here, it's going to say something on edit that says mark. So I'm going to mark what area do I want to copy. Okay, so I'm going to click on this all the way down here. That's all I want to mark. And if I push enter or Control C or edit copy, it is in my clipboard. Now I come to my program all the way to the end. I am going to insert /*, enter. Well, I can put it right here. We can say sample run, and then I'm doing Control V as a paste, Control V as a vector, and then I'm going to close my comment. So that's one way of bringing my sample run at the bottom. Okay, now I want to go over the CLion. So if I run CLion, what happened to my CLion? If I run my CLion, okie dokie, my computer just froze. Okay, here we go. Okay, so I am going to be running my CLion. Something is happening to my CLion. Okay, so if I run it, it's going to create a window down here, and it's going to run it for me, hopefully. With the CLion, it's giving me a hard time right now. What you can do is here we go. So you can actually go here and you can copy this, right click, copy, or Control C, come back here, put a / sample run. And then you can do Control V to save it over there, */. Okay, so there is an activity at the end of this. Okay, I guess so the activity, again, do your activity. This is supposed to say section 2.5, and do this activity and be ready to talk about it in the class.